Hi, welcome to the section 3. Welcome to the section 12.3 notes, inscribed angles. So here we go with more circles. Inscribed angles, they have a vertex on the circle and sides that are chords. Okay, so we can see here, and I guess let me go and talk about the intercepted arc is an arc that is intercepted by an inscribed angle. So if you look at this example over to the right, you can see that AD is a chord. We said that it is a segment that has both endpoints on the circle. We can see that CD is a chord. It has both endpoints on the circle. And so together, those two segments make an inscribed angle. So we can see that angle D here is the inscribed angle, where the vertex is actually on the circle at D. Okay, and then AC is the intercepted arc with that particular inscribed angle. It's basically the intercepted arc that meets up with that inscribed angle, because we can see, this endpoint and this endpoint of the angle meets up with that particular arc. So the deal here with the inscribed angle is the measure of the inscribed angle is half the measure of the intercepted arc. You can see the little formula here that angle D is equal to 1/2 of arc AC. So again, if you can just remember that relationship, that if angle D is an inscribed angle, it's half of what the arc is. Or if you know the inscribed angle, you can double it to get the arc. Or if you know the arc, you'll half it to get the angle. Okay, we talked about central angle. Central angles have the vertex at the center of the circle, and the central angle is equal to the intercepted arc, where again, the inscribed angle is half of what the arc is. Okay, so if we're finding some of these missing measures, then we can see that if it is 116 from here to here, the intercepted arc, then we know that A is half of 116, which is equal to 58 degrees. Okay. On number 2, we can see that this right angle symbol here, we know that means that angle is 90, and this is the intercepted arc, which is what they're asking for, is angle A, so we know that it is double whatever the inscribed angle is. So we know that A is 2 times 90, which is 180, which is half the circle. Okay, on number 3, this picture is a little more busy, more going on, but you can still figure out some of these missing pieces. Okay, we can see that angle PQT is 60. It meets up with this arc A, and so we know that arc A has to be double the 60. So we know that A is 2 times 60, which is 120. Okay, so that's one of our answers. And now we can see that B meets up with this arc from here all the way to here. Okay, well, if we know that A is 120 and we know this little section right here is 30, then if we add those up, we get 150 for this blue arc that I have. And angle B meets up with the circle, where this 150 arc is. And so we know that angle B is half of that 150, which is 75. Okay, so next up are some corollaries to the inscribed angle theorem. So corollary 1 says 2 inscribed angles that intercept the same arc are congruent. So these are things that should make sense based on what we just talked about. If this is the intercepted arc, and angle A meets up with that arc here and here, and angle B is an inscribed angle that meets up here and here, then again, if both of A and B are inscribed angles and they both meet up with the same arc, if you take that arc and half it, that is what both of those angles are. So therefore, angle A and angle B must be congruent. So again, it makes sense. Corollary 2 says an angle inscribed in a semicircle is a right angle. So I know that if this is the diameter, then I know that's half the circle, which is 180. And so angle C is an inscribed angle that meets up with half the circle, which is 180. So 180 divided by 2 gives me the 90. So I know that's a right angle, and therefore that's a right triangle. On corollary 3, it says the opposite angles of a quadrilateral inscribed in a circle are supplementary. So what that means is that the opposite angles, so angles across from each other that are inscribed in a circle, must be supplementary. So angle A and angle C are supplementary, which means they add up to 180. And angle B and D add up to 180. Okay. All right. So if we use some of that, we can find some of these missing pieces here. So on number 4, I can see that angle 1 meets up with the diameter. So I know that measure of angle 1, since it's 180 for half the circle, that angle 1 is 180 divided by 2, which is 90. Okay, that's all they're really asking for on that one. They kind of gave me more information than I actually needed. Sometimes that's kind of to try to trick you, but that's all you need to do on that one. On a 5, we can see that angle 2 is an inscribed angle that meets up with this arc, and the 38 is an inscribed angle that meets up with the same arc. And so we just said that on that corollary number 1, that therefore these two angles must be congruent to each other. So measure of angle 2 is equal to 38. And again, we didn't need to use that 70. The other way to do this one is to say 38 times 2, which gives me 76. And then once you know that arc, you'd go 76 divided by 2 to give me angle 2, which is 38. You're back to where you started. Okay, on number 6, this goes along corollary 3, where we said opposite angles of a quadrilateral inscribed in a circle are supplementary. So I know that P plus 90 is equal to 180. So therefore P is equal to 90. And I also know that Q plus 58 is equal to 180. So Q is equal to 122. Okay. All right. So then on number 7, again, to get C and D, I could go ahead and use what we just did here. We said that opposite angles of a quadrilateral inscribed in a circle add up to 180. So I know that C plus 96 is equal to 180. So I know that C is 84. Okay, I also know that D plus 100 is equal to 180. So D is equal to 80. Sometimes it helps you to put them in the picture once you find them. Okay, and so now I can find some of these missing pieces. I know that, let's see, if this 100 is right here and it's an inscribed angle that meets up with the arc here and here, then I know that from here all the way around to here has to be double the 100, which is 200. And so if 99 is part of that big arc and I want to know what A is, I can just say A is equal to 200 minus 99, which is 101. Okay, so that helps me get what A is. And then to get what B is, I can see that, let me get another color in here. I can see that angle C, which is 84, meets up right here and here. So I know that this arc from here all the way to here is double basically what the 84 is. So if I go 2 times 84, I get 168. So I know that purple arc is 168. And I know what A is, which is 101. So I can just go say that B is 168 minus 101, which gives me 67. Okay, so just use one of the rules to find the missing things. All right, the tangent chord theorem says the measure of an angle formed by a tangent in a chord is half the measure of the intercepted arc. So this basically works the same as the inscribed angle. It doesn't look exactly like an inscribed angle, but it works the same way. So in this case, we've got a tangent, like in this case, BC, and a tangent. This is actually the tangent. The tangent, again, skims by the circle and forms a right angle. Or I guess just touches the circle at one spot, and then the chord has both endpoints on the circle. And we're saying that that this angle has to be half of what this arc is from here to here. Okay, so this angle right here is half of what that arc is. Same idea here. If this is a tangent and this is a chord, then I know that this angle from here to here is half of what the arc is from here all the way around to there. Okay, so that's what we're using now. So it says find the missing angle measurements. So again, if W is this angle formed by a tangent and a chord, then W has to be half of this whole arc, which is 246. So W is equal to 246 divided by 2, and that gives us 123. Okay, here on number 9, we can see that if this angle is 115 on the left here, from here to here, then I know that E has to be 180 minus that. So E is 65. All right, and then whatever this angle is, I'll go and write it in here, 65, then F has to be double that. And that gives us 130. All right, and then on number 10, it's just kind of using a combination of different rules we've learned about circles so far. So in this particular case, we know that arc A is an inscribed angle. A is an inscribed angle that meets up with this arc, 52. So for A, I can just say 52 divided by 2, which is 26. Okay. And then we can see that C, angle C, has to be half of the 84 because it's an inscribed angle. So C is 84 divided by 2, which is 42. And then in this case, we can see that this segment is a diameter, which is half this, cuts the circle in half basically. And so we know if this arc is 52, then I can go 180 minus 52, which is 128. So I know that this arc over here is 128, and B, angle B, has to be half that. So B is 128 divided by 2, and that gives me 64. Okay. On number 11, again, different orders of things you can go in here. I know that if this angle, which is the central angle, is 44, then I know that this arc is 44 from here to here. Okay, but now angle A is an inscribed angle that meets up with that arc. So I know that A has to be half that, which is 22. All right, and then I can see here to the right that it's telling me that XY is 160. So I'm going to add that to my circle. So from X all the way to Y is 160. So that might come in handy. I also know that let's see. So basically that's what angle C is. That is what they're asking for. I know that it's 160. So they're just telling me that. All right, and then I see that B has to be half of the 160. Which is 80. All right, last few here. So on number 12, I can see that angle arc A has to be, since this is the diameter, which is half the circle, then I know that A is 180 minus 95, which gives us 85 for A. All right, and then B, I can tell, is an inscribed angle that meets up with the arc 95. So I know it has to be half of that. So B is equal to 95 divided by 2, which is 47.5. Okay, and then I can see that C meets up with the diameter. So since the diameter kind of cuts the circle in half, which is 180, and C meets up with that, then I know that C has to be 90. So 180 divided by 2 gives me, gives me 90. There we go. All right, on number 13, we can see that arc A has to be double what the 25 is. So A is 2 times 25, which is 50. Okay, I can see that B meets up with the semicircle, and so B has to be 180, which is half the circle, divided by 2, which is 90. And I can see that C also meets up with the diameter, which is half the circle. So it is also 180 divided by 2, which is 90. All right, and then last one on number 14 says that a arc angle A, inscribed angle A, has to be half of the 108 because that's where it meets up here. So A is 108 divided by 2, which is 54. All right, and then B is an inscribed angle that meets up with the 60. So B has to be 60 divided by 2, which is not looking very good, but it's supposed to be 30. All right, and then C, a few more steps here on C. What I would recommend here is we have just said that A is 54. And we just said that B is 30, and sometimes that helps to put things like that in the picture. So we can figure out what this little angle is right here, because we know that all the angles of a triangle add up to 180. So if we add 54 plus 30, we get 84. And so since if we go 180 minus 84, then we end up with 96. Okay, so here, if we know that this angle is 96, and we see that these are vertical angles, which must be congruent, then we know C also has to be 96. So that was a good way to get that one figured out. All right, so let me know if you have any questions, and have a good day.